Greetings, my fellow software test engineers, and welcome to my YouTube channel, Software Test Automation Revealed, STAR for short. This episode is episode 6, part 1, where I'll be demonstrating the best way of storing test results in a database so that it can be used for aggregate reporting after your tests are done executing. But first, would you please click that like and subscribe button so you can be notified as I produce new episodes and upload them to YouTube for you. Thank you. So when we store results in the database, we're going to be getting a collection of results, and it's going to look like this. We're going to have test result 1, test result 2, test result 3, and one of the things you will notice is you can have different test results for different countries and different language combinations. This is the way it would look if you looked at the data in MongoDBCompass. Now, how do I get different countries and results? How do I get that different combinations? Well, using our software testing solution, we are going to be setting the target country and target language to different values. So here I've got EN US, here I've got EN Canada, and here I've got Canada French. So I run the test once with each of these combinations in order to get the 3 different kind of results. I get, I'm going to get one result record each time I execute the test. Okay. Those result records look like this. This is the first half of it. Notice we've got a whole lot of data, not just pass or fail indication, but we're also going to be storing a lot of test metadata, such as the test name, the test description, which comes from the test. You can have a list of test case IDs. So for every test case your test covers, you can have that recorded. You can also have a list of test categories. So if your test covers more than one category, you can document that. We're going to document what testing environment our test ran in. We're going to document the country, the language. We're also automatically going to document which browser the test ran in, along with that browser's version. We're also going to record what was the name of the machine that ran the test. So this will be the name of the machine in which the test code executed on. We're also going to record the operating system that it was run on. We're going to record whether or not it was on a continuous integration server. We also want to record what was the test input data used to drive the test. We also are going to record what time was the test executed at and how long that test executed. The rest of the data, I'm sorry, this time and duration, that's part of the test input data, not when it was recorded or not when it was executed. Yeah, this is test input data. This is also test input data. Here, so this is the end of the test input data. Here's when we were recording actually when the test executed. And the test duration is right here. This test duration is in seconds. So this example, it was 6.625 seconds. Here we are recording the outcome of the test. We're also going to be capturing the log. So as our test executes, we are generating the log. We're going to be capturing that log and storing it in along with our test results. And finally, we're going to be recording a couple of files. So these files are IDs to files, and I'll show you that a little more later. What does this represent? So what we can do is we're going to be capturing a screenshot when the test fails. That will be one of these files. We can also capture what was the full HTML at the time of failure. That would be that other file. These file IDs, these are the object IDs or record IDs stored in MongoDB, because what we're going to actually do is we're going to actually upload those files into MongoDB's grid file system. And when you do that, what you get is a file ID. We're capturing that file ID here. Okay? So now let's go ahead and look at the actual code that's doing all of this. The main starting point is right here in this teardown. Teardown is an NUnit attribute. What that does is it tells NUnit, please run this method as soon as the test is finished executing. So you don't need to tell your test, each individual test, to please log all of that data. The NUnit test runner is going to automatically call this method, I call it test cleanup, after the end of every single test. So like this test. So when this test is done executing, NUnit is going to take over and it's going to switch and begin running this method, this test cleanup method. Now, this part has already been done. We covered this in a previous episode. What we have added is all of this code. We're capturing environment variables. I'm going to kind of assume that we were running on a GitLab job as a GitLab runner. In GitLab, it produces these environment variables. Now, project ID, that's the unique GitLab project ID stored. So your source code repo has a project ID, and that's what that is. When you execute a pipeline, I'll explain pipelines in a moment. Every pipeline that gets run gets a pipeline ID. Pipeline is kind of like a test suite. And then every job that runs as part of the pipeline. See, a pipeline will do multiple jobs in parallel. Every job has its own ID, so we're also going to be capturing that as part of our metadata. We want to do that, and now we're going to create this new object called a TestResultsMetaData. That has a whole lot of data, and let's take a look at that structure right here. So this is our TestResultsMetaData. The first thing, every MongoDB document has basically an object ID. With C#, we're going to translate it into a GUID. We have to store a GUID. Then we want to capture the test name, the test description, test case IDs, which is, notice, it's a list of integers. And then test categories, you can have one or more. It's a list of strings. We're also going to be capturing the target environment, the testing environment the test ran on. We're going to be capturing what country and what language did we run our test in. We also want to capture which browser did the test run in, along with the browser version. We want to capture the machine name, along with the operating system, and whether or not we were using it on, the test was being executed on a continuous integration server. Here, we're capturing the test input data, the time the test ran, how long it took to run, the outcome, and the log. The log is nothing more than an array of strings. And then we're also going to be capturing the build ID, which would be your continuous integration build ID. In the sense of GitLab, that would be the GitLab's job ID. And we also have, if it's a GitLab, we have the GitLab pipeline ID. And project ID, that would be the unique project ID in your source code repo. And as well as we want to store the branch name. So you can have multiple branches. You might have a master branch, a develop branch, a feature branch. We also want to capture the branch name, which can be captured out of when a GitLab job runs. It also tells us what branch was being used to run that. And then we finally, at the end, we have a list of object IDs, which point to the files in the file system being stored in MongoDB. All right, now these things are kind of special. These are MongoDB special attributes. What we're saying is, if this value is not set, meaning if it's the default value, which happens to be a null, then during serialization, MongoDB, the driver, will not even store these values. So that's what it means with ignore if default. It means skip storing these values in MongoDB. if they are the default value. This one is a special attribute also for MongoDB. It's just saying, hey, MongoDB, basically treat this as a document, a unique document ID. All right, let's go back to here. Now, so we're going to be creating this new structure, this test results metadata structure. Test name, that is coming out of the NUnit full name. So the full name is going to be the fully qualified class name. So for example, you've got the namespace Star.Tests, and then we've got a class name, and then we have our method name or test name. So what you would see for full name is Star.Tests.DinnerPageTests.CreateDinner. That would be the full name that would be stored here as the full name for the test name. Description, we're also going to capture description from the test. So when we look at the test, we see we have a description attribute. Now you can only have one. With NUnit tests, you're only allowed to have one description. You cannot have more than one. This text can be anything you want. This is just going to be you put in the description for the test there. And then we also capture these test case IDs and test categories, which, if you notice, also come from attributes. So you can have a property. You're allowed to have more than one test case ID property. So in my example, I just said test case ID 1 and a 2 and a 3. Of course, put in your real test case IDs from whatever you use for your test case ID control system. And we also have category. We can have multiple categories if we want. I just gave the category create. This category is nothing more than a string. You can put in whatever category you want. And of course, you can have different tests can be using the same category, and it's probably a good idea. You know, your categories might be more like feature names. So think of this as a feature name. You know, what kind of feature is the test testing? So put that here in your category. All right. Then environment, we're getting that from the application settings. So target environment, the target country, the target language, that comes from our application settings, which is being driven by the app settings. So the app settings will have the target environment, that's your testing environment. You're going to have the target country as well as the target language. Those three will be captured and stored here in these values. And then for browser, we're going to call a method to say, go and fetch the name of the browser. It's actually going to, there's a method it can call to determine what type of browser was being used to execute the test. We also have a way of capturing the browser version. I'm not going to go over that code during this lesson. You can download this source code and look at it yourself. And the machine comes from an environment variable. This being a Windows environment, you can just simply say environment.machineName to get the name of the machine. Now the operating system, we're going to be calling getOperatingSystem. So we have a method for determining and fetching the name of the operating system. The onCI, that's coming from a parser. So we're going to parse an environment variable, and we're going to store, basically it's a Boolean, a true, false, are we or are we not being executed on a CI system. So the default value would normally be false. So if you're running locally and you're running in debug mode, this normally would be false. What you want to do is when you're running on your CI system, you want to set this variable to true so that the code knows that, hey, this is being run on a CI system and it might slightly change the behavior of the test. Now here, we're going to be capturing now all the test input data. So the test input data is being stored in our global data cache. And here we're just going to be pulling it out of the global test data cache and saving it as part of our test results metadata. And then here we're going to be capturing test start time. So test start time, that was, we took a snapshot of the current date and time when the test began execution. And then we also have a timer running. So here, test duration becomes current date minus start time. So we're going to be capturing, okay, just how long did the test execute? And then we also have the outcome. That is coming from NUnit. So we're going to get the NUnit test status, convert it into a string, and then we're going to store that string in the test results metadata. And then these are just simply capturing basically the environment variable, which is the build ID, the pipeline ID, and the project ID for GitLab, as well as the branch name coming from the environment variable. So this is a GitLab environment variable that holds the branch name. And now we're going to be, this is not actually capturing the files. This is just creating a list. So we're initializing a new list to hold the object IDs for the environment variable. Now we come down to here. So we have our structure created. It needs a few more things added to it before it can be pushed into MongoDB. We're going to say if the test failed, now we're going to do this code. We're going to call a method that says StoreFile into, and this is where to store it, and the name of the file to store it as. What we're going to capture is the page source. So we're actually going to make a call to the Selenium WebDriver and get the page source for the current page and store it into MongoDB using this, using all of these details. We also want to store what was the file type being used. And this also stores some additional metadata. So when you look at the files being stored in MongoDB, and we'll be getting to that here in a few minutes, you can see this metadata being added to the file. So when you look at the file itself, you've got some way to backlink that file back to this test result. We're also going to go and take a screenshot. And this is taking a fairly intelligent screenshot. So if you've got a web page that is very, very long, longer than can be fit on the page itself, what it's going to do is it's actually going to take multiple screenshots. It's going to take screenshot 1, and then it's going to scroll the window, and it's going to take another screenshot of the second part of this page, and scroll some more, and take another screenshot as many times as is necessary to capture the entire web page all at once. And then it's going to concatenate those separate screenshots into one large screenshot and save that. That's what this TakeScreenShot does. It's able to concatenate them all together, and now it's going to store that as a screenshot into the MongoDB grid file system. And we're also going to put into our logger what was the URL at the point of the failed test. Now this did not change. We haven't changed this. Here we're just going to go ahead and shut down the WebDriver itself. And if there happens to be an error while shutting down, well, we'll log the error and then we'll just go ahead and continue. Basically, more or less silently ignore any fatal kind of error that happened during the test shutdown. Now we want to shut down the logger. We want to make sure the logger is fully closed and the files are closed. And then we can say, read the lines from the log. So we created a log. There's a log file out there. We want to read it into memory. And now we can say results.log. So results, that's the name of this object. So we created the results. We called it, created this test results metadata structure. We named it results. And here we're storing the log into it. Read line gives us and to array gives us an array of strings that can be stored as the log. And now, finally, we're ready to publish the test results. So we say publish test results, and we give it the object to publish. We also give it where to save it. So notice we're pulling that from the appsettings.json. So we can look at that and see in app settings, this is being used as our connection string. That's the same connection string we used for fetching the test input data, so that did not change. But these two are new. So we're going to store it in a database, MongoDB database called TestResults, and we're going to store it in this collection called Pro-Dinner Test Results. And I'll actually show you that database here in just a few moments. Let's go back to here, and we're going to add test IDs to the results file. So back up here, we saved a couple of files, but we would like to have some links in these files back to this test result. When we stored these files, though, we didn't have the metadata stored in here. So we didn't have a document ID to link these files back to the test results. But now that we have published the test results, that publish gave us back a document ID. That's a MongoDB document ID. So we want to go back into those files, and we want to basically append the result ID. In other words, the ID of the result object, the result document that we just saved in MongoDB. So we'll go into this method, but first let's have a closer look at this publish results method. Let's go into that definition here. So you can see this code is actually not that difficult. We generate a serializer here. This is going to be used for the serialize method, which is right here. We're using that writer, and we are serializing our metadata object into this BSON writer. So it's going to be serializing it into this variable called BSON writer. So now we have what we want to do is convert it into a BSON document. That's something that can be stored in MongoDB. So even though we have a writer, we don't really have an object yet that we can push into MongoDB. So this gives us an object, a BSON document object that can be pushed into MongoDB. So now we create our connection to MongoDB. So we establish a connection, we select our database, which came here as a parameter, and we select which collection to store it in, which came as a parameter right here. And now we do the insert. So we finally say collection, insert one, the BSON test results. So we're finally pushing the object, the BSON object containing our document, into MongoDB. Now that that insert is done, it actually updates the ID element, so we can return that ID back to the calling method. So that returns that ID, the result ID right here, which we can then use to say add test IDs. We're going to say add the test IDs into MongoDB here. So let's go into that method. So this is that method, add test IDs. Again, we have to make a connection. We have to make a connection to our MongoDB database, just like before. Now this is a special collection name, this fs.files. This is where the files are stored as part of the MongoDB grid file system. Then we also have to create a set. We have to create a set update for setting the files. So this creates an update for adding the result ID into this result ID to the files already stored. So now we go through a loop. We say for each file that we saved, we're going to update it, and we're going to set, basically, we're going to set the, this is going to be a metadata, and we're going to set the file ID using the update command here. All right, so let's have a look at the data in MongoDB so you can picture out, so you'll be able to visualize that a little bit better. So here is our Pro Dinner test results. See, we've got 3 different records. And if I open up one of these, I can say, edit this. And if I want, I can say update. No. All right, I want to see that into, yes, of course. I can, okay, I can look at it this way. So we can see here's document number 1, and document number 2, and document number 3. This is our unique document ID for this document. We've got our test name, our description, our test case IDs, the environment, all of this. Now we've got our test input data, which is another object. This is all the data that was used for the test input. We have time run. It is stored as an object as well. The test duration. We've got the log, which is, it's not clear to see here, but it is an array of strings. And then we have our files. So we only have saved 1 file with this result. And this one was also only 1 file. This one also was only 1 file. Now the files are stored in this, we've got fs.file and fs.chunks. fs.file it's kind of like a directory. In the fs.files, we have the length, chunk size. I'll let you look that up. That's a special MongoDB attribute. MD5 verifies the integrity. And then metadata is something I created, and metadata is being added to each and every file. So in this metadata, I've saved a content type. I've saved the test name. You can see there's the fully qualified name of the test and the result ID. So this is the ID of the result document that file matches. That is then repeated for all of these files. So you can see, if you look real carefully, you can see this result ID would match one of these. In this case, it would match this one. Okay. That's mostly it in terms of these documents. Now in part 2, which I'll do, I'll have a part 2 episode I need to work on and put up. I'll be showing you how can you pull this data out of MongoDB so that it can be usable. Because obviously, yes, we've pushed a file in here, but this is not, and you can't see the HTML, you can't see the pictures, the images. They are stored in here in these chunks, but it's stored as chunks as like raw binary data. So we need a method to be able to pull these out so that they are usable. So we're going to need to be able to pull these out, convert them back into HTML, convert it back into JPEGs so that you can look at them and view them. Okay, let's go back to our code and see what other changes have we made. The test result, so let's see, base web test. Let's look at the other changes made to base web test. Yes, I had to add a few more using statements. I had to keep track of the path to the log file. I had to keep track of the test input data, so this gets saved when the test runs. And that actually is being saved now by the test itself. So when we look at the test, this is what I added. I added the description, test case IDs, the category, There's also now a new method for capturing and saving the test input data. So every test that runs, when it pulls the test input data, needs to also save it using this method so that it can be stored along with all of the test results. Okay, let's go back to based web test here. And the other changes we had to make, this is the property for saving the log file path, which now that's being saved here. So when we're creating a logger, I'm saving the path to where the log file is. Okay, test duration is something new we added here. And then this is all of that new code I just went over, for parsing the environment variables, creating our new results object. This is the new code for capturing those files when the test fails. And we've also got the new code that we had to add code for shutting down the logger, as well as reading the log and storing it into the results metadata, as well as adding the test case IDs. This is not really important. Added some additional comments. Capture test input data. So this is the, so that's the method for capturing the test input data. And I've got some commented out code. Let's just get rid of that. We don't need that. All right. Test data provider was the other thing we looked at. Needed some more using statements. And this is what we just went over. Storing files, this is something we really did not cover. So let's cover that in more detail. Store test results, data provider, storing files. All right. So it takes a database name, the name of the, basically this is like the name of the file that you want to be stored. This would be what data to be stored. So if you're storing an HTML, this would be the HTML. If you're storing a JPEG, it might be something else. So we have to create a bucket for storing the data in. And now, right here, we're creating our metadata object, which we attach to every document. And then we finally add the metadata, additional metadata. So this is metadata. So you can pass in this dictionary with additional metadata to be passed in. Here, because we know the bucket type is being fed in here, so we're just going to convert that to a string and store that. And then we're going to expand it with the additional metadata passed in. And then finally, we're actually uploading the bytes to be to the grid file system in MongoDB. Now, there are two versions of this store file. The difference is this one takes a string, and this one takes a file. So this is the one we would be using for storing things like the HTML, the page source. This one would be using for storing raw files, such as when I take a picture, a JPEG picture, I'm creating a JPEG file, and now I want to upload that JPEG file this way. So that's the only difference between these two. These open a file and upload the file as a file stream, versus this other method, it takes the datum and encodes it into, just does ASCII encoding of it and uploads that string directly to it. All right, other changes that were significant. Let's see, this WebDriver, what did we do here? Yes, so I'm not going to go in great detail. This is the advanced TakeScreenShot method. So this is the one I talked about. It says, okay, it takes a screenshot of the first part of the screen. We'll scroll the page, take another screenshot, scroll the page, take another screenshot. And now it's going through it'll be going through the operation of merging all of those screenshots into one large screenshot and saving that as a JPEG file. The data repo, yes, we made it better by adding getters and setters to each of these, and I had to add a whole FS repo object to be used for storing files to MongoDB. We went over the test results. We went over this, the application settings. All we did was we added these two parameters to our application settings for capturing the test results database and test results collection. So this just tells the test where to push the data to where to push the test results to. And the base web test, yes, we just went over that. Application settings, again, all we're doing was we're adding the test results database, the test results collection, and the dinner page, we went over that already. We added the description, these properties, this category, and capturing the test input data. All right. I'm not going to execute any tests. We've executed tests in the past, and it really doesn't, the tests execute fast, that really didn't change. Everything here that really changed was saving the results, which really is not visible when you execute the test. Okay, so I appreciate you looking in, and so thanks again for tuning in. And once again, please remember, click that like and subscribe button so you will be notified when I upload part 2 of this episode, which will be all about retrieving the test results from the database. All right, thanks and have a good day.